Scene script. Have you ever pondered how much of the universe remains unseen to the naked eye? You see, our eyes are impressive tools, but they only provide us a sliver of the universe's full story. As we gaze up at the night sky, we're only seeing a fraction of what's out there. There's a vast array of light in the universe that our eyes simply can't perceive. This is the universe's invisible light, the light we can't see. It's a fascinating concept, isn't it? That the universe has a secret language, a hidden code, narrating tales of celestial bodies, cosmic events, and distant galaxies that our eyes can't comprehend. Now, you might wonder how we know about this invisible light if we can't see it. Well, that's where the electromagnetic spectrum comes in. You see, light is a form of electromagnetic radiation, and the spectrum of this radiation extends far beyond the visible light that our eyes can detect. The electromagnetic spectrum is like a grand cosmic key, unlocking the hidden parts of the universe. It encompasses everything from radio waves, used by our favorite radio stations to send music through the air, to the gamma rays that are produced in nuclear reactions and supernova explosions. Imagine for a moment that the universe is a grand symphony. Our eyes can only hear one instrument, visible light, but the electromagnetic spectrum, it allows us to hear the entire orchestra, each type of light playing a unique part in the cosmic concert. With the electromagnetic spectrum, we can peer into the universe's secretive corners, unveiling cosmic wonders that remain unseen to the naked eye. We can capture the whispers of distant galaxies, observe the life cycles of stars, and detect the remnants of the universe's birth in the cosmic microwave background radiation. And all of this is made possible by the universe's invisible light, the light that our eyes can't see, but that the electromagnetic spectrum can decipher. So, what exactly is this electromagnetic spectrum that allows us to decipher the universe's invisible light? Let's dive deeper into that in the next scene. The electromagnetic spectrum, in simple terms, is the complete range of all types of light. This spectrum is a map of light energy that's organized by wavelength and frequency. It's a fascinating concept that goes far beyond the visible light that we perceive with our human eyes. Now you might be wondering, what kind of light are we talking about here? Well, let's break it down. The electromagnetic spectrum is a broad spectrum that encompasses various types of light: radio waves, microwaves, infrared, the visible light that we can see, ultraviolet, X-rays, and gamma rays. Each of these types of light has its unique properties, determined by their wavelengths and frequencies. Let's start with radio waves. These fellows have the longest wavelengths and the lowest frequencies. They're used in, well, radio broadcasting, but also in television signals and even satellite transmissions. Next up are microwaves. They're smaller than radio waves, but still relatively large. You might associate them with heating up your leftovers, but they're also used in radar technology and telecommunications. Then we have infrared light, which is even smaller. This is the stuff that night vision goggles use to detect heat from bodies at night. The visible light, the one we see, is a tiny part of the spectrum. It's made up of all the colors we can see, from red with the longest wavelength to violet with the shortest. Beyond violet, we have ultraviolet light. It's invisible to us but can give us a tan or a sunburn. It's also what makes white clothes glow under black lights. Then we have X-rays, even smaller and more energetic than ultraviolet light. They can pass through our body and let doctors see our bones. Finally, there are gamma rays. These are the shortest and most energetic waves in the spectrum. They're used in medicine to kill cancer cells, but also come from nuclear reactions and distant cosmic events. Understanding these different types of light is the key to revealing the universe's hidden secrets. Each type of light in the electromagnetic spectrum has its own unique role and properties. Let's dive in and explore each one, starting with radio waves. These are the longest waves on the electromagnetic spectrum, and you might already be familiar with their role. Have you ever wondered how your favorite radio station reaches your car's stereo, or how your television receives signals for your favorite shows? That's radio waves at work. They're used in broadcasting, telecommunications, and satellite communication. From chatting with your friends on your mobile phone to watching a live international sports event, radio waves are the invisible threads connecting us. Next up, we have microwaves. Don't let the name fool you. They're not just for heating up last night's leftovers. Microwaves are shorter than radio waves and are used in radar technology and telecommunications, as well as in your kitchen microwave. The energy they carry can stimulate water molecules, causing them to vibrate and generate heat. So, when you're warming up that cup of coffee, it's microwaves that are making those water molecules dance. Then we come to infrared light. This type of light is invisible to our eyes, but we can feel it as heat. Ever used a remote control to change the channel on your TV? That's infrared light at work. It's also used in heat sensors, night vision goggles, and even in some types of therapy to promote healing. Now let's talk about the star of the show, visible light. It's the only part of the electromagnetic spectrum we can see, and it's essential for life on Earth. Plants use visible light for photosynthesis, and our eyes use it to see the world around us. Without visible light, our world would be a dark and unseen place. Moving on to ultraviolet light or UV light. This type of light has shorter wavelengths and carries more energy than visible light. It's used for sterilizing medical equipment and purifying water, thanks to its ability to kill bacteria. But remember, too much exposure to UV light from the sun can be harmful, so don't forget your sunscreen. Next we have X-rays, which are even shorter and more energetic than UV light. X-rays can penetrate our bodies, which makes them incredibly useful for medical imaging. Thanks to X-rays, doctors can see inside our bodies without having to perform surgery. Finally, we reach the end of the spectrum with gamma rays. These rays have the shortest wavelengths and the most energy of all. They're used in medicine to kill cancer cells and in scientific research. But due to their high energy, they can also be harmful if not handled correctly. These types of light, although invisible to us, are crucial for life as we know it. So, the next time you heat up your dinner, watch television, or even step out into the sunlight, remember the indispensable roles these different types of light play in our everyday lives. But how do these different types of light help us understand the universe? Well, let's dive into that. Astronomers are like detectives, using all the tools at their disposal to unveil the mysteries of the universe. Different types of light, or more accurately, different parts of the electromagnetic spectrum, provide unique insights into the cosmos. Take radio waves, for instance. These long wavelength signals can penetrate dense interstellar gas and dust, allowing astronomers to observe distant celestial bodies and phenomena that might otherwise remain hidden. Moving to the shorter wavelengths, we have infrared and visible light. These are great for studying stars and galaxies. Infrared light can reveal cooler objects in space, like brown dwarfs or the cold outer rings of galaxies. Visible light, on the other hand, gives us a clear view of the universe as we would see it with our own eyes. Then we have ultraviolet light, X-rays and gamma rays. These types of light are associated with some of the hottest and most energetic phenomena in the universe. Ultraviolet light can show us areas of star formation, while X-rays and gamma rays reveal high-energy events like supernovae and black holes. Each type of light, each part of the electromagnetic spectrum, is a key that unlocks a different door to understanding the universe. By combining all these keys, astronomers can assemble a comprehensive and multifaceted view of the cosmos. By studying all types of light, we can get a complete picture of the universe. So, to summarize our journey through the electromagnetic spectrum, we've covered quite a bit of ground. We started by introducing the concept of the universe's invisible light. This light, which our eyes can't see, is an integral part of the cosmos, revealing secrets that would otherwise remain hidden. Then we delved into the electromagnetic spectrum. This spectrum is an array of different types of light, each with its own unique characteristics. From radio waves, with their long wavelengths and low frequencies, to gamma rays, with their short wavelengths and high frequencies. Each type of light plays a distinct role in the universe. We also explored these roles in detail. We learned that radio waves help us probe the farthest reaches of the cosmos, while infrared light lets us peer through cosmic dust clouds. Visible light lets us see the universe as we know it, while ultraviolet, X-rays and gamma rays uncover high-energy events like supernovae and black holes. Finally, we looked at the universe through the lens of the electromagnetic spectrum. We discovered that by using different types of light, we can gain a more comprehensive understanding of the universe. This light helps us see the unseen, unlocking the mysteries of the cosmos. Next time you gaze up at the night sky, remember that there's a lot more to the universe than meets the eye.